In this video, we are going to see about advanced engine technologies. Already we have seen about low heat rejection engines in the last video. Here in this session, we are going to focus on six-stroke engine concept. Six-stroke engine concept is one of the upcoming real-time concept in which the prototyping and research is going on. In real time, the six-stroke engine concept is not there. Only two-stroke CA engine and two-stroke SI engine, two-stroke CA engine, two-stroke SI engine, and four-stroke CA and SI engines is there. Six-stroke engine concept is there, but it is not applicable in real-time engineering industries. We are going to see why it is not applicable and what are the process which is happening in the six-stroke engine concept in this video. In six-stroke engine, generally there are 6 processes. We will see one by one. Generally, the six-stroke engine is the engine type in which a power cycle is completed by the revolution of 3, which is in which the piston is connected to the crankshaft and the connecting rod. If the piston or crankshaft rotates 3 times, the power stroke getting completed. That is the basic concept of six-stroke engine. Generally, in two-stroke engine, the power stroke is completed within one revolution of the piston or crankshaft. So in here, six-stroke engine, it is multiplied by 3. So the 3 revolution of the crankshaft, the power cycle, connecting rod, which makes a power cycle for the engine. So in this six-stroke engine, there are 6 major processes. The first one is intake of fuel. The fuel is getting intake into the combustion chamber. This is the first process. It is intake with the help of the vacuum pressure which is created inside the combustion chamber. How the vacuum pressure is getting created? When the piston moves to the top dead center, the amount of vacuum pressure is getting created. Due to the creation of vacuum pressure, outside there will be atmospheric pressure. It is around 1 atm. So from the high pressure to the low pressure, vacuum pressure is around, which is less than 1 atm. So always, according to the law, it will move from high pressure to low pressure. Due to the movement of fuel from high pressure to low pressure, the fuel is getting injected through the intake valve. This is the first process. After the fuel is getting intake into the combustion chamber, the piston is getting compressed. Due to the compression of piston, there will be a power stroke will come into picture. The first process is intake of fuel, second one is compression stroke, third one is power stroke, and the fourth one is removal of exhaust gas. So after the removal of exhaust gas, there will be a secondary power stroke in six-stroke engine. Generally in the four-stroke engine, these are the two-stroke and four-stroke engine, these are the process. Whereas in six-stroke engine, there will be additional 2 processes. The 2 processes are secondary power stroke. After the exhaust gas is removed, there will be a secondary power stroke will be coming into the picture. After the secondary power stroke, there will be a removal of exhaust gas again. So this exhaust gas is removed after the secondary combustion, secondary power stroke. These are the basic 6 principles, 6 stages which is occurring in six-stroke engine concept. But why the six-stroke engine is not applicable in real-time engineering? It is because it makes so much amount of cost to create six-stroke engine. In six-stroke engine process, there will be addition of water droplets when the combustion is occurs. Due to the more amount of temperature will getting rise inside the combustion chamber. It is around 900 to 1000 or more than that, the temperature inside the combustion chamber will be there. So to reduce that, to the precaution of the thermal risk, we have to add the water droplets. So for adding water droplets, we have to maintain or design a separate water container. So this makes an extra cost. So I am telling the reason why it is not applicable in the real-time industry. The first reason is cost. We have to add or we have to spend more amount of money for creating this type of six-stroke engine concept. The next one is it will make an extra space when we place the water container for adding the water droplets into the combustion chamber to reduce the temperature, we have to take some amount of space, so that will space compactability, and it does not meet the standards in ISO, Indian Standard Organization, or many of the standards. There will be some amount of standards. This dimension only you have to design, you have to manufacture. For the 6-stroke engine, till now there is no standards, and this is one of the reason, and it is not suitable in cold conditions. Cold conditions in the sense wherever the temperature is very low, because we are adding water. Due to, if the 6-stroke engine is adding water in the cold conditions, for example, if you take any kind of hill regions when the temperature is very low, if the added water is added, then the bike or any kind of vehicle, cars, will not start due to this process, because we are adding water. So it reduces the temperature which is inside the combustion chamber, leads to the low starting of engine, non-starting of engine. And another reason is in BS6, already I have told in one video about BS6. In BS6 already the emission norms and other things which is already have been done, so we don't want to go for 6-stroke engine. Already the system is there. Why we need to go for 6-stroke engine? So in BS6 itself we have designed a proper emission control, and these kind of things we have done. So we don't need to go for a 6-stroke engine concept. And the advantages of 6-stroke engine is it has high thermal efficiency, and which also having a better thermodynamic efficiency, and which uses a low fuel during the combustion process. That is one of the major advantage in the 6-stroke engine process. It takes low amount of fuel. It has less BSFC. BSFC means brake specific fuel consumption. It is a ratio of amount of fuel is consumed per second to the brake power. That is the basic definition for BSFC. Here the fuel consumption is also very less. This is also one of the advantages, and the NOx emission is very less compared to the other engines. Due to the reduction of NOx engine, high thermal efficiency, high thermodynamic efficiency, and also having a better cooling process is the advantages of this 6-stroke engine concept. But in real time it is not applicable in industry. There are many of the researchers are working on in this kind of 6-stroke engine process, and prototyping is also going on. So I hope this video is useful for you. Thank you.